So good morning students. Today we are going to discuss one very nice question. So these kind of questions no you can expect in GE mains, but I don't know why they have asked in GE advance. It's so simple question. Most of you are telling, sir, first time. No, I am also a student only now. So my friend came at the end of the exam. He told, "Hey, first question even tough question. Last confidence." I also checked it. First question, easiest question. Thing is that you people are forgetting one thing. Okay, let's come to that. But before that, some of you will be watching without knowing the basics, no? So we'll once read out the question for you people. A small coin is placed on a stationary horizontal disc. Okay, this is the horizontal disc and we are placing one coin over here. And what they are telling is that the coin is placed at a distance r from its center. Okay, that we can call it as the radius, initial radius, because now we are going to give an angular acceleration. Because of this acceleration, angular velocity, that angular velocity will keep increasing. Okay, it's an increasing function since the alpha is a positive constant. Okay, they have given it is a constant. Okay, since the omega value is increasing, you tell what is the now you can feel that at a particular point of time when the disk starts rotating very fast, the coin is going to slip and fall outside. Okay, but when will it fall outside? That is the question. That is the question. When will it fall outside? First question, that is to ourselves. We are asking ourselves when it will fall outside. When will it fall outside? When the friction value that is opposing the coin to fall outside is greater. It's lesser than the force, external force applied. What is the external force here? Centrifugal force. And another force called tangential force is the it's alpha is there. Alpha is not zero. This is the most important thing. What you people are thinking? Only centrifugal force is pulling outside, so directly we equate F is equal to m omega square, not capital F, small f. Mu mg is equal to m omega square. That is the mistake number one, and you will proceed. You want to get answer. You will see the option. See, this is the options. What is this? What are these options? Nothing is matching with my option. See, nothing is matching with my answer. Tough question. Let's see it. Mistake number one is that you are not seeing that alpha is there. When alpha is there, tangential acceleration is there. Cha. Tangential acceleration is there. Now let me tell you net force. What is the net force? The force that is acting outside. Or you keep consider it as the no, you take it like this even. This is the centrifugal force. So what is the centrifugal force magnitude m omega square r whole square plus what is the tangential force r, that's okay, smaller. Let's not confuse you. R alpha the whole square equal to mu g the whole square. Sir, okay, okay, understand. M R M. Okay, forgot the thing. My mistake. Okay, but unfortunately, you are bad luck because I am winning. Because M is going to get cancelled. You can see no. Both LHS and RHS, if you take M common out, you'll get cancelled. So I'm not mistake here. Now let's say why am squaring, sir? Don't ask. Means you don't know anything in physics. That's why you're asking these kind of questions. If this is the force acting in x-axis, I cap I direction, and this is the force acting in another direction that is perpendicular, and how will you find the net force, ra? Obviously by squaring only. You need to square and take root, but instead of taking root I am squaring the other quantity also, so that no need of taking root. Okay, so these two force components are being balanced by what? Friction. Friction value only m mu g or is mu mg. Okay. Now since I'm cancelling m on both sides, you will get omega power 4 r square plus alpha square r square equal to mu square g square. This understood now? Okay. Now let's what we need to find. We need to find omega. So let's find omega. No problem. Are omega only we need to find? I hope so. Let's. What are they asking first? First, you need to know what they are asking. They are asking how much number of revolutions will the coin. This is a coin, not a ball. Okay, the coin will make before slipping. So that means they are asking a number of revolutions n. What is n? We know that 2 pi n is equal to omega. So what is n? Omega by 2 pi. To find n, you need to know omega. To find omega, we can get from this equation. How can we get from this equation? Omega power 4 r square equal to mu square g square minus alpha square r square. Now let's transpose this r square here. R square. This can be simplified as mu g by r whole square plus alpha square. Okay, so this is the value. Am I making any mistake here? No, no, no. Okay, this is omega by 4. We need omega, man. What is omega? Mu g by r whole square plus alpha whole square whole power 1 by 4. This is the omega value. Understand now? Okay, let this be as it is. Now tell, now tell. So let's compare the options. Are am I making any mistake? It feels I'm making some mistake. I need to get 1 by 2, not 1 by 4 here. What is the mistake? Tell me. Square g square minus r square alpha square divided by r square. We are getting omega square r, squaring it. Okay, fine. No mistake up to now. Okay, no. Okay, see, we have given alpha value. I mean, alpha is there. Up to this angular velocity, the particle is going to be balanced by friction force. After that, it's going to slip. So, can we tell that omega square equal to 2 alpha into theta? Can we tell? Yes, we can tell. Why not? We can tell that omega square is equal to 2 alpha theta. Why omega square, sir? V square is equal to u square plus 2a's formula you know, but you don't know omega square is equal to 2 alpha theta. Wow. But now square it. If you square this quantity, automatically you get 1 by 2 over here. See, at the beginning, even I didn't get the idea. I got 1 by 4 here. Okay. Now just compare with the options. So options given only power 1 by 2. So what can be done to make the power 1 by 2? We need to square. Then we need to change this omega square with something. Then imagine that case, you'll get it. No difficulty. Now, instead of this omega square, let me write 2 alpha theta. Fine. Okay. Now, I will find 2 theta equal to, no, let me find theta even. Mu g by r whole square plus alpha square power 1 by 2 divided by 2 alpha. Now tell number of revolutions, how to find? Number of revolutions is going to be theta by 2 pi. So definitely 2 pi is one revolution. Theta is going to be greater than 2 pi or less than 2 pi. Even it's less than 2 pi, no problem. 0.5 revolutions. It's possible, no? Half revolution. Half revolution is equal to what? 0.5. 0.5 is greater than 1, huh? No. So theta by 2 pi will get. So if this is theta by 2 pi, then obviously you need to divide it. No space. Very bad there. Directly will do. No problem. I'll directly write 4 pi alpha. Now tell. What is this? Oh my god. See, I made a mistake in exam. What answer we are getting? Plus no. You have kept minus here. So your correct answer will be first option. Arey no Ravi. I have done correctly. Here only you made mistake. See, this is minus no. This is minus. This is minus. I was just shocked. Oh my god, minus 2 marks. No. I am correct only in the exam part. Now only I am wrong. Okay. So your answer is going to be, I hope you can see the paper. Second option, mu g by r the whole square minus alpha square divided by 4 pi alpha over 1 by 2. So this is going to be your answer. So number of revolutions, let me denote it by n. Since the question is denoted by yeah, pen cap is also getting tight. Life is getting difficult. No. Okay, fine. So this is how I will advise you to solve this question. Let's just recap once. This is the centrifugal force, this is the tangential force. The net magnitude of this will be equal to the frictional force. Yeah, upon simplification, this is blah blah blah. You can do it. Okay, finally we'll get omega square over here. Omega square can be replaced as 2 alpha theta. 2 alpha theta like this means theta value we can write it as 2 alpha. Since I'm dividing it by 2 pi, you will get 4 pi alpha. Such an easy question. Okay, just took 11 minutes and 36 seconds. Thank you.